In this video, we're going to revisit PICmicro instructions as a group. Um, Earlier, we had gone through and discussed the 5 types based on the way they're organized and type of operation they do. We have talked about 5 types of instruction. We talked about byte-oriented, bit-oriented, controlled operations, and the literal would put get a constant, put it in the W register, and manipulate and work with the constants. And then we had mentioned, but really hadn't discussed that heavily, was the memory block moves. Now, if you look at the instructions we want to look at it from a different perspective a little bit of if you're trying to use this, if you're just simply a programmer who wants to use this instruction to program, or maybe we are a compiler writer, we are trying to see how best to compile a high-level language to this particular assembly code. Then another way to look at it is kind of grouping the instructions in a little bit different ways, and it's always good when you're working with a microprocessor to take just a quick look at the different kinds of instruction it provides from a functionality point of view. If you notice, there's a whole group of functions that deal with the byte. They either add bytes, subtract bytes, multiply bytes, uh, rotates them. They do some sort of a logical or mathematical operation. They may be also doing that with a constant or whatever, which is mostly happening here, and then so that's one grouping. Then there's another group of instructions that's very useful, especially if you're trying to build if then else's loops and things like that. And as we've talked, these are the compare and skips, or decrement and skip, or increment and skip. And what they do is they basically take a action, and then they would compare whatever register you have with the W register typically, and then if it's if meets a certain condition, they would skip the next instruction. Some of them are a little bit different. For example, if increment F skip if 0 will basically increment whatever the F register is, and if it's 0, it would skip the next instruction. If you don't like that, the next one is not 0, it skips if it's not 0. So these are useful, especially when you're trying to build a loop or a if then else. The other one is a bit-oriented set of instructions. Again, they are in 2 groups. There's a couple of them that just simply sets or erase it or toggle the bit. There's a couple of them that is actually testing to see if a certain bit is set, and jumping the next instruction again is a very good tool to building case statements, if then else, and things like that. And then the next group is a whole group of branch instructions here, including calls and go-tos and all of that kind of stuff. Then we have a couple of instructions which, especially this one, is very unique, where if there is a concept of watchdog timers in microprocessors, where you would like to make sure that the microprocessor still is executing valid code. And the way that we make sure that is happening is that the microprocessor is set to reset itself if there is a certain instruction is not executed. In this case would be clear watchdog timer. So if you don't do that after I believe it's 100 millisecond for this one, it will reset itself. Now, in typical sample codes we've written, we've also always disabled the watchdog timer. But if you're doing a sensitive device, that is very important to know if it's operating properly or not. It's really important to not disable it and actually use this instruction to clear it. A couple other things. Pop and push we talked about when we did the stack, and of course we got the return from interrupts, and we got returning something, a literal value in W register. So those are somewhat useful. This is useful if you want to go wait for something, but you want to be in a standby while you're waiting. So, and then wake the system up because of an interrupt or some other feature. So those are some of the like the sleep and um, the reset is another one we haven't talked about it. If for whatever reason you get into an error condition that you can't recover, you just want to go back to the beginning and start over again, this reset function might be useful for you to use. Okay. So that's all the branching tools that are available. This one I think it's relatively straightforward. It's just basically pushing a constant, dealing with a constant, doing all the operations we've done before, except it's doing with a constant. The one exception is LFSR, and this has to do with indirect addressing, and we will cover this in much more detail in future lessons. So LFSR is used for indirect addressing scheme. Okay, that brings us to the end of this short video, kind of walking through a instruction and kind of pointing out what the different instructions are. It's always a good idea to have done at least once, walk through all the instruction and spend a few minutes looking at each one. So when you need something, you can have a recall of, what I think there was an instruction that did this, and you remember it. And the last one, which we have kind of mentioned on the passing a few times, but really haven't done much with, is the table moves. And this is where we want to do a block move of a certain part of memory to data memory to another location of data memory. This will be very useful. They can auto increment, auto decrement. You just tell them start here and this is how far you gotta go, and it'll do the move for you in whatever order you like it to be done. Okay, that brings us to the end of this video.